Welcome back to the shop and to the channel. Got a little side project here I need to work on. I've got this 10-inch 4-jaw chuck for the 1960s South Bend lathe that didn't have a backplate. So I ordered up this partially machined one from Shars, and the task now is to make it fit. The first thing I want to do is take a couple of measurements here on this new piece. This inner part of the bore that's next to the threaded portion, I want to make sure that the inner bore there is big enough that will fit over top of the unthreaded portion of the spindle. Well, I like to say if you like these kinds of videos, please give it a thumbs up down below. It really does help with the algorithm, and it helps me know what kind of videos people would rather see. If you don't like this video, give it a thumbs down. Leave me a comment. Let me know why you like it, why you don't like it. If I try to thread this onto the spindle, and I want the back of that backing plate to register all the way up there, and it looks like it's about 1/8 of an inch short, and so I have the feeling that this inside bore is just a bit too narrow. I tried getting a micrometer on this unthreaded portion, and it's barely fitting on there, but I don't think it's really going to be all that accurate of a measurement. So what I might end up having to do is just to kind of do this by feel. I'm going to use the other lathe I have to machine that bore out, and I'll use the 4-jaw chuck here to go ahead and chuck up that back plate. I'll need to reverse these jaws around first so I can get a good purchase on the outside of that back plate. With the jaws now switched around, I can chuck up this backing plate, and then we'll dial it in. It's a little tough to see the inside where the boring bar is making contact. So I put a little Sharpie here on the inside of the bore so I can see when I touch off. So I'm going to bring the boring bar all the way in until I'm close to the threads, and then I'll feed the cross slide out until I touch off. I'll engage the power feed to feed outward from the chuck. I don't think I need to take off more than a couple of thousandths. So once this finishes up, we'll do a test fit on the lathe. Well, and just in case I want to come back to this lathe to take a little bit more off, instead of removing the part, I'm going to remove the entire chuck and take it over to the other lathe. Over here at the green lathe, I think I'll just call this the green lathe, I can thread this back plate onto the spindle and check the fit. I'm going to call that perfect. So I don't think I'm going to need to do any further machining on that part of the back plate. I'll just go ahead and loosen the jaws on the small 4-jaw chuck and just take it off, leaving the back plate threaded onto the spindle. With this back plate threaded on here now, you can see there's an awful lot of thread that's not engaging on the spindle thread. And that's because this back piece is just a bit too long. And I want to shorten that. And I think the easiest way to do that is just to spin it around and install the back plate backwards on the spindle and just go ahead and cut it down a little bit shorter. And this is about when it dawned on me that I didn't need to use that other lathe at all. I could have just flipped this thing around and skimmed the inside of the bore until I was going to get a good fit. Oh well, lesson learned. I'm going to use a parting blade here to shorten this back piece. Who knows, I might be able to use this ring for something else in the future. These cast iron pieces are so easy to machine, but they do throw up a lot of dusty little parts. And here's where I realized too that I think I still have some issues with the motor on this lathe. It seems that when it gets cooler out, this motor has less and less guts to it. I used this lathe a little bit over the summer and was able to make some decent cuts with it. But now that it's started to cool off, I recorded this in November of 2023. Here in Northeast Ohio, it hasn't gotten very cold, but it's certainly gotten down into the 50s. My shop being unheated, that means that everything in it is in the 50s. And I've noticed here using this cutoff parting tool, and you'll see it later in the video, that for whatever reason this motor has a tendency to stall, and I'm not exactly sure if it's just an old motor or what, but I think my intention is going to be to replace that motor anyway. I actually wouldn't mind bumping this up to a 2 horsepower motor versus the 1.5 horsepower that's in it. Well, with that piece parted off, I'll go ahead and put in a turning tool here and clean up the face a little bit, and then we'll break those edges with a chamfer tool. I'll pop this off and turn it around and give it a test fit. Well, one of the things I was afraid of, and although it's not a big deal, is because I've made that bore shorter, the threads now interfere with the unthreaded portion of the spindle. So I'll need to turn this back around and machine out at least one turn of those threads. I think that should be enough for it to register up against the end of that spindle shoulder. Off camera, I did need to clean up the thread start where it got machined away, just to get it to clear properly on the spindle nose here, and it fits in there real good. It registers up against the shoulder of the spindle, and I think I've got just a little bit of clearance on the front. So now I need to turn my attention to machining the diameter of this thing to fit the recess in the back of the chuck. The inner bore of the back of the chuck is right on 6 inches. So I'm going to start here by taking a cleaning cut on the outside of the back plate so I can get an accurate measurement. And this is what I was referring to before. That was a 10,000 depth of cut, so 20 thousandths off the diameter with a sharp carbide turning tool on cast iron. It should have no problem cutting that. And why I am is likely going to be a motor issue. I don't believe it's in the spindle, but it's something I'll definitely need to address. It does mean it's just going to take me a little bit longer to machine this thing than I was hoping. Well, I know it's definitely not a belt issue because the belt would just be slipping, and this is actually the motor bogging down. Could be something in the spindle bearings, but it felt pretty good. Maybe it's in the lower pulley bearings. I don't know, but I'm going to start digging into this lathe here soon. So this is really kind of going to be my last opportunity to use it anyway, because I'm going to start tearing it apart. I've got a 6 to 7 inch Starrett micrometer here that I picked up at an auction a little while ago. We'll take a measurement here and we'll start turning this down until we get a little bit close and can try some test fits. Well, before I do a test fit, I do want to break the edge on this piece. It is very, very sharp. It will cut you. Ask me how I know. This is probably not going to fit. I think I'm still a few thousandths, 5 thousandths away, but I want to check before I go too far. We'll give this another check, and I think that's right where I want to be. I can feel it wanting to go on, but I do believe that the boss on the front of the backplate is wider than the center hole on the back of the chuck. So I'm going to go ahead and face this down a little bit, take a little bit of the thickness off. But then I'm going to need to bring that center boss down so it registers to the inside of that chuck. And of course, this thing is really one of the most awkward things to measure because I can't really get close to it. And I need to try to get this to be accurate because I want it to register nice on the inside of the chuck. You know, the more I can make this thing a nice tight fit, the more rigid the chuck will be and the better surface finishes I'll end up with. So what I think I'm going to end up having to do is just to take a little bit off, get where I think I'm going to be close, and then do some test fits. And just keep going back and forth until I feel it kind of go completely flat onto the inside of that recess. Well, I think I only need to take another 1 or 2 thousandths off of this boss and it'll fit in there really nice. I got the chuck body and the backing plate over here on the bench. I want to get everything clean and get this lined up so I can see where I need to drill some holes. I think that fits in there perfect. It's not stiff to where I have to press it in, but it's a nice, comfortable sliding fit. Go ahead and turn this thing over so I can transfer the location of the mounting holes onto the back plate. I use one of my transfer punches that fits nice and snug inside this mounting hole, and we'll go ahead and mark the location for the 3/8/16 threaded holes I'll need to put into the back plate. I like to take a Sharpie and circle any of the punch points that the punch made just so I don't lose track of them. On this piece, it's not an issue, but I've had it an issue before. And I'm going to take another center punch and just make it a touch deeper. We'll come over here to the bridge port and we'll get this clamp down to the table. I'm going to line at least one of the holes up with the table slot I'm going to drill these one at a time. Probably completely unnecessary, but I got a couple of scraps of aluminum here that I'm going to use to kind of spread the clamping force out across a little more area on the back plate. I'm going to use a wiggler to individually locate each hole. I suppose I could take some measurements and figure out a PCD pattern to plug into the DRO, but quite frankly, this is a lot easier and is probably going to end up being more accurate anyway. It's pretty simple to use. Once you get it spinning, just use something like a back of a paintbrush to settle the wiggler down so it's running fairly true with the spindle. And then with it spinning, you just move your table until that tip of it is right over top of your punch mark, and you can bring the quill down and actually locate it even closer. I've had really good luck using this in the past. Well, with the hole located, I've got a 120-degree spotting drill in the chuck, and we'll spot this hole before we drill it for the tap hole size for 3/8/16. There's a small gap between the back of the back plate and the surface of the mill table just because of that threaded boss that's on the back there. So I got a piece of wood stuck in there. I don't think this drill is going to hit the table. It looks like I lined it up in the slot, but just in case, I put that little piece of wood back there, and so when the drill hits that, I can feel it, and it won't do any damage to the drill, and it protects the table from bozos. With the hole drilled to size, we'll give it a nice chamfer to make it easier to start the tap. I'm going to use some anchor lube here as a tapping lubricant. Not really necessary on cast iron, but the thing I do like about it is it helps carry some of the swarf away, because it's a fairly thick fluid, so it kind of captures the finer swarf junk and helps it get it out of the way. Obviously, I did not plan this out very well, because if I had, I wouldn't have put this thing so close to the vise. Alright, I'm going to get a wrench, and we'll go ahead and loosen the vise and shove it over to the left, which also means at some point in the future I'm going to have to tram it back in, although that process really isn't all that difficult. With the vise out of the way, I can tap this hole now unimpeded. I do want to take a second to thank Anchor Lube again for being a supporter of the channel. I've been a user of this product for years before that ever happened. It's an excellent product. I can't recommend it enough. And if you'd like to try some Anchor Lube, there's a link down in the description that takes you to their Amazon storefront. Well, I thought I could tap this unimpeded, but my clamping bolt is a little bit too tall. So I'm going to have to get creative with this one. I'll fix this for the other three. Well, before I start drilling and tapping for the other three holes, we'll change this clamp setup so I can at least get the tap wrench down all the way. I've got a shorter stud that I'll use, and I think I have something else I can use as a clamp that will spread at least a little bit of the load. It won't be as good as the two pieces of aluminum, but I think it's going to be fine. It doesn't really need to have that much clamping force. Well, I want to make sure that this punch mark is as close to over the center of the slot as I can. Again, just to kind of give me a little bit more insurance that I'm not going to damage the table. Not a lot of thread engagement on that nut, but I think it doesn't need a ton. It should be fine. We'll get the wiggler set up here in the chuck again and locate this next hole and drill and tap, and we'll do this 3 more times, and when I'm done with that, we'll go ahead and bring it back. Well, we've got the machining complete for the back plate, so now I just need to mount it. Before I do want to make sure everything is clean, and we'll go ahead and spend a little time deburring the back of this just to be sure that there's nothing left behind that could affect the concentricity of how it engages with the chuck. Well, after stoning these surfaces down, I'm just going to wipe this down with a rag and then, kind of feel it with my fingers. Make sure there's no dust or debris left behind. Well, I'll get this first hole lined up. I have 4 3-inch long socket head cap screws, and we'll get all of them started before tightening them down. With the back plate now secured to the chuck, we'll bring it over here to the lathe and we'll thread it on the spindle and we'll see how it looks. Well, it might be difficult to see this on camera, but the face of that chuck has got a bit of a wobble to it. A lot more than I expected. I want to set up a dial indicator just to see how far this is out, so I can figure out what I might need to do to correct this, or if I need to correct it. I'll randomly pick a starting point to set my 0, and then I'll just kind of slowly turn the chuck around and down some measurements at a few locations. Yeah, I'm getting a spread of something like 15 thousandths, maybe a little bit more between the high point and the low point. I'm going to need to think about what I need to do here. I'm going to take a measurement on the outside and see if that's as bad. Is it the face of this thing, or is the whole thing out of whack? Well, taking some readings on the outside, the diameter, and I'm seeing a lot of run out here too. 3 to 5 thousandths, probably about a 7 thousandth spread. So I need to step back a little bit. I'm going to take the back plate off of the chuck and re-examine this. Maybe there's a burr underneath there that I missed. Well, off camera, I went ahead and took the chuck off of the back plate. I ended up re-skimming the face of the back plate again. It didn't seem to take any more off of any particular side. Cleaned it up and reassembled it. I must have had a chip in there or something that I missed. So everything's running true now. Set up a dial indicator and we can see the results. Well, we got the dial indicator back up on the face, and I might be getting, maybe 2 thousandths of an inch difference here, and that's at the 10-inch edge of this 4-jaw chuck, which I think is pretty respectable considering its age, and it is a little bit on the beat-up side. And if I bring this up to the face of the jaws and the middle step of the jaw, I'm not even getting maybe a thousandths of run out overall, and I think again that's really good for this chuck considering its age and considering its use. I'm more than happy with that. Well, with the chuck ready to go, I don't know that the motor is, but at least the chuck is. I'm going to have to investigate the deal with that motor. Maybe there's something I can do to get it to warm up a little bit better when I need to use it. Well, I appreciate you watching. If you like this video, give it a thumbs up. Leave a comment down below. Let me know what you think. If you're not a subscriber, please consider subscribing. And for all those that have supported the channel by subscribing or joining Patreon, I thank you very, very much. Thanks for watching, and we'll see you on the next one.